Now for this one here, a plane flies a straight course on the ground directly below the flight path. Observers 2 miles apart spot the plane at the same time. The plane's angle of elevation is 46 degrees from one observation point and 71 degrees from the other. So you see the picture right there. We are looking for the height of the plane. The problem is, I know that there's 2 miles between the two observers, but, when I measure the height of the plane, it's going to be measured from, a path that's perpendicular to the ground. You see that path is actually intersecting the ground somewhere between where the two observers are. So, the distance is, I have some right triangles being formed here, but I don't really know any of the side lengths. I know that like two of the side lengths of those right triangles, they share the height, and the other two legs add up to be 2 miles, but I don't know what each individual leg measures to be. And that's the issue I have here in finding h. But here's what I am going to do. I'm going to first label h as being the height. We're going to assume that those are right. That is a right angle there, because when I measure height, it should be perpendicular to the ground, assuming it's level ground, and we're not being told otherwise, so it's a safe assumption here. I'm calling x the distance from the first observer, the one that has a 71-degree angle of elevation when looking at the plane, to the point where the height, is intersecting the ground. And I'm going to let the other one be 2 minus x. Again, that's coming from me having 2 miles altogether, and that would be subtracting x, whatever that would be, to figure out what that length is. And the reason why I'm doing this, and I'm trying to put it in terms of one variable, is because I'm going to probably need to figure out some way of determining what x is in order to help me find what h is. So here I'm going to have some interdependency here, because I don't know the hypotenuses. I don't know anything else in these triangles. So here's an instance where I'm going to probably need to use some previously calculated values. And you also notice there I set up two tangent functions, because tangent of 71 degrees is going to equal h over x, and that left hand right triangle, and the right hand right triangle, the tangent of 46 degrees is going to be h over 2 minus x. And therefore, if I solve each one of those equations for h is going to equal x times the tangent of 71 degrees, and it's also going to equal 2 minus x times the tangent of 46 degrees. Now, one thing to keep in mind as I do this, tangent of 71 degrees is a number. I'm going to treat it as a number. I'm going to treat it as the whole quantity as a number. I'm not evaluating what that number is yet, because if I do so, it's going to be irrational, and I'm going to have to round it at some point. And therefore, I would already start rounding, and then each subsequent step I do would be more rounding, more rounding, more rounding, more rounding. I don't want to do that. And same thing with tangent of 46 degrees. I'm not going to do that there either. That does take away my ability to combine some like terms, because they are numbers, and therefore I'm going to have to be really careful about how I do some algebraic simplification. But ultimately, what I'm going to be able to do here is I can set up an equation where I set these two equal to each other, because they both equal h. And then what I could do is solve an equation for x. So I can say that x times the tangent of 71 degrees is going to equal 2 times the tangent of 46 degrees minus x times the tangent of 46 degrees. I'm going to get all my x's on one side, so I'm going to add x times the tangent of 46 degrees to both sides. Because of the fact I'm not evaluating what the tangent of 71 degrees and the tangent of 46 degrees are, they are numbers, and under most circumstances here on the left hand side I'd be able to combine like terms, because I have a number times x plus another number times x, so I would just add those two numbers together. The problem is, I don't have those written as numbers. I have them written as the tangent of another number. So in order for me to get x to a point where I can isolate it on one side of the equation only, I'm going to factor that out and have on the left hand side now x times the quantity of the tangent of 71 degrees plus the tangent of 46 degrees. All that's going to equal 2 times the tangent of 46 degrees, which means that x is going to be 2 times the tangent of 46 degrees all over the sum of the tangent of 71 degrees and the tangent of 46 degrees. That whole mess is what x would equal. Okay, I'm going to go back to the first equation I got, for h, and say that, okay, well, h is going to be x times the tangent of 71 degrees, and now I know that x equals that whole quantity I just came up with. So h is going to be the 2 times the tangent of 46 degrees over the sum of the tangent of 71 degrees plus the tangent of 46 degrees times the tangent of 71 degrees. It ends up becoming that whole quantity you have to the right there. And then now I can evaluate that. Put that in my calculator, make sure I'm using parentheses appropriately or my calculator appropriately to group things together correctly. And I get that height, it's about 1.53 miles. So if I'm doing it this way, I'm only rounding once. Instead of rounding, instead of rounding in each and every step I did. 20. Laura Burnett is 5 feet 4 inches tall. She stands 10 feet from a streetlight and casts a 4-foot long shadow. How tall is the streetlight? And what is the angle theta? One of the issues we have here is 5 feet 4 inches is a 2-unit measurement, and that's a problem. We can't really do calculations with 2-unit measurements dealing with trig functions and Pythagorean theorems and things of that nature. So I got to take that 5 feet 4 inches and turn that into a single unit of measurement. So that's the same thing as 5 1/3 feet. I can say 5.3 repeating feet. Even repeating decimals gets to be a bit of a pain to deal with. So I'm just going to call it 16/3 feet. That's at least an exact number. I'm not rounding anything when I use it. And I'm going to fill in the rest of the information down here. So I have her height being 16/3 feet. I have 10 feet from her to the lamppost. I have 4 feet, the length of her shadow, which means if I look at the distance from the lamppost to the tip of her shadow together, that's 14 feet. Okay. What I'm going to do here is, how tall is the street light? What is the angle of theta? Now, there's a couple ways to go about doing this. I could actually find the angle theta first and then use that to find out what the height of the street lamp is. We also have a situation here that deals with, if you remember how to use them, similar triangles. I'm going to kind of use that first. And the fact of the matter is, these two triangles, I have a bigger triangle that has H being, that vertical side, and 14 being the base. And these are both right triangles. I don't have them labeled as such, but we're assuming they are because usually lampposts are made perpendicular to the ground. And I have another triangle similar to it, 16/3 over 4. They have the same angle, being having the opposite legs and the adjacent legs here. So the tangent of theta is h over 14. It's also 16/3 over 4. And since theta is the same angle in both of these, and the tangent should be the exact same, I can say that h over 14 equals 16/3 over 4. These are things that you learned about also in geometry dealing with similar triangles. And in geometry courses nowadays, they often talk about the trig functions because trig functions are a direct result of similar triangle information. So h over 14 equals 16/3 over 4. I don't like having a fraction with a fraction, so using my rules for fractions, again, you're expected to know. 16/3 over 4 is the same thing as 16 over 12, which is 4/3. Okay, so h over 14 equals 4/3. So if I work this out, cross multiplying, 3h would equal 4/3, or 4 times 14, which would give me h equaling 56 over 3. So the height of this lamppost is 18.6 repeating feet, or 18 2/3 feet, and 2/3 of a foot is 8 inches. So it's 18 feet 8 inches. And it's another thing you want to be aware of, the fact that oftentimes if they use mixed unit measurement as a description, then you can expect to give a mixed unit answer as well if need be necessary. So the height of that lamppost, as most accurate as possible, is 18 feet 8 inches tall. Along with that, we worked this out before, that we had that h over 14 equals 16/3 over 4, which equaled 4/3. 4/3 is the ratio for the tangent of theta. The tangent of theta is 4/3. So if I do the arctangent of 4/3, that'll tell me what the angle theta is, and that's 53.13 degrees. So again, we're using that inverse trig function. The street light has a height of 18 feet 8 inches. The angle of elevation there, going from the tip of her shadow to the top of that lamppost, which is what theta was, is 53.13 degrees.